All right, guys. Well, today's the day. We're gonna talk about that thing over there with the hood up. So it's come to my attention that my F100 is starting to make more noise than it usually does. It's always had like piston slap and miscellaneous stuff like that. I'm used to that because it has a tapered bore. I built the motor in 10 hours, so I was expecting noise. It's always had noise. It's never been an issue. It's had a gnarly piston slap before I went to Arizona and before I did that massive burnout. So all that stuff was already known. But now, after taking it out to the Classic Stanks Cruise, which isn't anyone's fault but mine, I was basically coming down Montezuma, pulling 6,000 plus RPM all the way up, down Montezuma into Borrego in the desert, and then all the way up into 5,000 elevation in Julian. Now I think because of that, it finally took a toll on one of the bearings. I don't know if it's a main bearing, thrust bearing, or rod bearing, but I think it's something in the bottom end. It could be a lifter or valve train related, but honestly, you guys can listen to it for yourself. I don't think that's what's going on here. So I ran it for a little bit and I took a video on my phone. I don't want to run it more than I need to, so I'm going to overlay that video right now. And as you can hear, that sounds like a rod. I've heard a lot of rod knocked engines, which is actually kind of ironic. This never had that sound, so now it does. And it was to the point where I realized it was down on power. It was making really funny noises. I had oil pressure fluctuations, which it stays high, but I have a feeling the sensors before all the bearings. So basically you have pressure going into the bearings, but you don't know what it is coming out based on where my sensor is on these motors. So, and then I broke the exhaust hanger on the back when I was driving it, so that's all hanging down low. And so that developed an exhaust leak, but that wasn't my issue. So I guess I'll go ahead and fire it up one more time, see if this camera can pick up better audio. I doubt it. Because I was filming with a different camera when I first had this issue. That doesn't have a good mic on it, so. Still runs really good too. Yeah, you can see it has perfect oil pressure. That's fine. But it runs a little bit iffy. Yeah. So you see how it kind of sucks my hand back in? So if you have a dead hole or a misfiring cylinder, it'll actually decel and suck air back in. So that's what's going on right there. You guys don't need to hear that. So that's great. Yeah, thing still runs really good. But I can hear one cylinder's not happy. So I kind of want to do a compression test, but realistically, I know there's something wrong with the engine. I'm just going to skip the whole process and pull it apart. So it kind of is that unfortunate event to where I was hoping I would have a second engine, because they do have a second engine for this thing that I was building. I was hoping I would have it done by now. By the time I broke it, which is kind of inevitable for me because you guys see how I drive this thing, I wasn't going to drive it any less hard to kind of prolong the engine life. I don't care. I drive my stuff the way that I drive it for a reason. That's why I build the engines. And I'm not trying to go for 100,000 miles with these engines. I would not be surprised if getting into it in the future, I put a different engine setup in my truck almost every year. That would not surprise me one bit. Keep in mind, it's been 1 year we've had this engine in. I built it in November, like the first week in November, because we didn't go to SEMA, so we went to Dino's Get Down the week after when SEMA was, or would have been. So we built this motor from Friday to Friday, put it in, we got it running in the driveway basically from a Friday to a Friday, pulled the old motor out all the way apart, machined this one, put this one together, and it's still running. So I'm pretty happy with that. I can't complain there, but I'm definitely not driving it anywhere anytime soon, which is really kind of sad to think about. So I need to go ahead and put it in the backyard because there's no reason it's sitting out here. The dreaded backyard, so I get to play musical cars with this piece of junk. I finally got my insurance claim back for this thing, so I'm not really sure what I'm going to do with it. So you can see the whole back of it's all smashed up. I don't know, you guys can let me know what you think. I've had thoughts of getting rid of it. I don't know if I want to yet. I also could take that money and reinvest it elsewhere and then just do a junkyard thing. We were thinking about either, I don't want to just put the stock quarter panel back on this car. I was either going to make it a wagon and go to the junkyard and find a wagon version of an LTD and cut the back of that car off, make it a wagon, or I was going to section it right here and put truck bed sides on it and make it a truck. So I don't know, you guys can let me know what you would want to see. Would you rather see it a wagon or a truck, or should I just get rid of the thing? I don't know, it's so loyal. I can't even like fathom how loyal this thing is. I mean, the tent, it's comfortable, it's locked right now, but even the keypad works to unlock it. You can see inside of it, this thing's so comfortable. It's all business in here. The heater and the AC works beautifully. All the lights and everything works. I don't know, the car's got such a gnarly history besides what I show on YouTube with it. I mean, like, there's like 4 guys that have raced this thing in the desert. So the fact it's even still running, I don't want to kill it, you know what I mean? Resting place for a little while. I noticed a weird noise. I think the throwout bearing's probably going out. Check this out. It's like basically right when I push the clutch in, the throwout bearing starts like whining really bad. So it's something in the clutch mechanism is making a bunch of noise too. So that's great. That means the transmission would need to come out anyways. It's one thing after another with this truck, I swear. Right when I finally had everything all situated after we did the aluminum heads and the really good blueprint heads that are on this thing and all the other stuff we did to it, I thought it was finally good. But any good part's no match for my non-existent mechanical sympathy that I don't have for this thing. But it'll sit back here for a little while, but that's okay. It's okay. We're going in the right direction because we're gonna fix it the right way this time. I have a fully studded forged bottom end short block we're building for this thing. No corners cut. All the tolerances are perfect down to the 100,000th of an inch. We're gonna make this thing pretty stout. So, because get ready, because we have a nearly 8,000 RPM short block we're building for this thing. It's gonna make this thing absolutely shred tires. It's kind of a double negative there, but not break. 8,000 RPM, not break. I don't know, we'll see. But it does kind of suck bringing it back here, but it gives me another parking spot out front, and then I don't have to stare at it every single time I leave the house, realizing I can't drive it, which upsets me. So, gonna put it back here, relax for a little bit, considering every time I've driven this thing, I've smashed it to red line all the way past 6,000 RPM ever since we turned the rev limiter up. And I would like to admit it probably deserves a little bit of a break, to be quite honest. This thing's treating me pretty well, so it's all right. Old Mater will come back a little stronger. For those of you guys that don't know, the truck's name is actually Mater. But I guess enough talk about that thing. Let's go talk about our new engine. So if I walk over here, I actually got a shipment of parts pretty soon. I have everything but a crankshaft, so let's kind of go over what we got sitting over here. All right, guys, so let's talk about this new engine that I've been talking about. I have most of the pieces, so I'll kind of just start from top to bottom. The one thing we'll start with is the most important part is the pistons. So these are the pistons that will be running in this thing. You can see it's a forged Icon piston, 30 over, running a true 30 over, not a tapered bore this time. So I'm gonna go ahead and pull these apart, show you guys what we got going inside. All right, so like I said, this is a forged piston from Icon. This is a little bit different than what you would see in a stock motor. So basically, I'll give you the basic rundown. We have a 68 day coated virgin 302 block that came out of a 68 Ford. So it's perfect virgin over. His motor had never been apart. It's still standard bearings in it. There's a lot more videos on that specific motor coming later. It's out of a car that Sean owns. So I'll put it that way. But basically I stole his motor. It'll all make sense in the upcoming months, which I'll probably start uploading those videos pretty soon here in December. But anyways, I took his motor. I basically bought his motor off of him and traded him for a roller block so he can go roller. I took that block, sent it to a machine shop, had it bored 30 over and decked. So basically what we have is a perfect 30 over and decked 302 68 date code. Really nice block. It's pretty much as nice as you can get besides going to an aftermarket block. So what I ended up buying was these. So these are a set of Icon pistons, and these are actually the pistons that would have gone in a 331 stroker. So let me kind of explain the geometry of why I went with these. Alright, so I wrote this up real quick. This is just my crappy handwriting, but this is the simplest way that I could run through this with you guys. So basically, you have a 302, I'm talking about 8.2 deck motors. So this is a 302, 331, and 347 stroker. You guys are all common with those three. These are the strokes of the numbers. So you have a 3-inch stroke on a 302, 3¼ inch stroke on a 331, and a 3.4 inch stroke on a 347 stroker. Those are very normal numbers. The bore on these are all 30 over, which you can see right here. And then the rod length is a 5.09 on a 302, and both the stroker engines use a 5.4 inch rod. The rod ratio on this, which is basically down here, it's your your stroke to your piston ratio. So basically, the lower that number is, the closer it is to 1, meaning you have a 1-to-1 ratio of sideways to vertical travel, which is what you don't want. So the higher you can get that number, essentially you're losing low end torque, but it's less vertical force on the crankshaft, less horizontal force on the crankshaft, more vertical. So stock 302s, you can see it's a higher number than the stroker. The longer you make that stroke, the more sideways this crankshaft is going to move. Therefore, as you increase the stroke, you can see the rod ratio decreases all the way across. So the longer stroke motors have a more torque low end, because the more horizontal movement down low you have, more torque you have, but less higher RPM range power. So basically the compression height is basically from the center of the wrist pin hole to the top of the piston height. That is a 1.6 inch on the 302, and you can see it decreases as it goes down, basically because you have a longer stroke. If this number all the way across did not decrease as the stroke got longer within the engine, your piston would come above the deck height and smash into the cylinder head. So that has to be addressed. So what I am going to be building is basically a mixture of what's going on here. It's called a long rod 302. So this is going to be the engine in the F100 that we're going to be putting together. So it has a same 3-inch stroke of a 302. It's a 4030 over bore. Sorry, it's kind of messy handwriting. I'm going to be using the 5.4 inch rod from the stroker engines, but I'm also going to be changing up with a piston and running a 1.28 piston height. So basically, that leaves us with a 1.8 inch rod ratio, which is actually really good. That's about as high as you'd want to go. Anything above that, you're getting into like super dry sump NASCAR engines that make no torque and they rev to like 9 grand. So this is kind of a happy medium. I've seen this done before. These motors tend to live above 8,000, no problem if you got the right cam and oiling system in them. But yeah, like I said down here, you have a lower rod ratio, more side-to-side movement, less higher RPM. Because if this thing is going like crazy distances side to side and you want to spin it to the moon, that gives a lot of tension on that rod, which means you can very easily break a rod if you rev it that high. But if you have a shorter stroke and a longer rod, it's not moving side to side as much, therefore you can spin it higher and it'll survive longer. So if we can have a good valve train in this thing and make sure all the geometry gets squared away, this thing should work quite well. So this piston right here, which I'll go ahead and open up for you guys, is what's going to make this whole thing go together. So this is a Ford's Icon piston. It is 30 over, and you can see the dome on this thing. So go ahead and change back to an autofocus. Yeah, you can see. So this is, gosh, if I remember right, I did all this math a while ago. I think this was a 6cc dome, if I remember correctly. I'll go through the specs later, obviously, when we get all the parts and we go through the engine. But you can see how short this little guy is. This is not nearly as tall as a regular 302 piston. So this is a 30 over Ford's Icon piston. It's a dome, and this will basically, if I zero out the deck, so the deck height is basically how far down is this piston from the deck of the block. If I zero that out and run a 039 head gasket, which is your standard Felpro you see on pretty much any O'Reilly shelf, I'll have an 11.6 to 1 compression ratio. Now, I don't want to make this seem like I'm just this master engine builder and I know what I'm doing, but I just kind of looked into the engineering of things and the geometry. I've seen these motors built, I've seen videos and engine build blueprint setups on these things. The only thing I'm not sure about yet is our cam spec. So basically I'll put the whole short block together, I'll kind of measure everything out, measure out our tolerances and our compression ratio and whatnot, and then actually get on the phone with some sort of cam company I haven't decided yet. We'll most likely be be running a solid roller, because if you're going to spin a motor that high, typically we're going to have a big valve spring to prevent valve float. If we run any hydraulic lifter, the thing's probably going to fall on its face. So that's the problem we have with the current motor. It's got just some super cheap Chinesium comp lifters in it. They honestly suck. And anytime it goes past, you know, 6,000, I think the lifters are starting to like come apart. They're not holding, they're not pumping up, they're collapsing basically. So they can't withstand a true double spring. I have too heavy of a spring on it, but if I change the spring, I'll have valve float. So it's like one or the other basically. So I need a better lifter in it. So we'll either go to a minimum travel hydraulic lifter roller, or we'll go to a solid roller. I haven't decided yet. I haven't decided cam specs, but we're probably gonna go with a pretty high duration. You know, 280 is what's in it right now. The more duration you have in a camshaft, the higher it pushes that RPM curve and that power curve. So we're gonna probably be in the 300 to 280 to 300 plus. A Lamar cam, which is what's in the GT40 Mark 1 and like old Trans Am cars, those have like a 310, 304, 310 duration cam. So all those like Trans Am cars that rev to like 8,000 RPMs you see, the Boss 302s and whatnot, those things run some seriously aggressive cams. So I'm not sure how aggressive we're gonna go, because I do want to drive it on the street. But 11.6, we have another set of cylinder heads, single plane intake, fuel injection, direct coil and plug ignition. A lot of trick stuff going on this engine. So it's going to be fully studded from top to bottom, but let me go ahead and pull these rods out and I'll show you what I was talking about with the rods. All right, so these are the rods. So basically we have an Icon forged piston, Scat set of forged rods, and then currently I have an Eagle crank sitting down there, but that is a stock crank. It's just a cast replacement. That's not going to work. So I went ahead and purchased this rod. This is a forged H-beam rod, and I-beam would have been, you know, cut out in the center like an actual I-beam. So this one's cut out on the side. This one has a little bit more strength in terms of side-to-side movement. So they kind of do the same thing. I mean, there's minimal differences between them, to be quite honest. This is just what they had in stock for with the geometry I was going for, so I bought this. So these two will pretty much pair together like so. I'm not going to pull anything out of the bag yet, because a lot of stuff needs to go to the machine shop still and get all balanced and whatnot. But yeah, like I said, I don't want to go too in-depth with the motor yet, but the crankshaft that's down here is a stock 3-inch stroke cast replacement crank. It's an Eagle crank. It's meant to fit that rod, but the problem with it is it's an externally balanced crank. So one of the things when you're trying to shoot for that 8,000 RPM range, it needs to be internally balanced or something will come apart. You want to have the rotating mass on the crank as far inside as you can get it. So if we have an external balance, we're spinning weight outside of the crank that doesn't need to be there. So I'm going to pretty much ditch this crank and return it, and I got a forged, internally balanced 302 3-inch stroke crank. So that is going to be the crank that we're going to be running. It's a forged, internally balanced crank, forged H-beam rod, and a forged pop-up Icon piston. That, with all the geometry I just showed you guys, should pretty much guarantee it'll rev past 8,000 or 7,000 into 8,000 RPM range, no problem. Depending on the cam and the oiling system, obviously. So a lot of you guys are probably going to comment saying I'm going to split the block right in half. I've beaten the snot out of mine at 6,600 RPMs and it has had no issues, and that's a 71 date coated block that has a tapered bore and a lot of other things not really going for it. So I don't really know. I'm here to test it, so I don't know how high I'll rev it. I probably won't rev it higher than 8, to be quite honest. I think on the dyno I might, just to see if it'll do it. But realistically, I think it's not going to get street driven much higher than 7,500. I think if I can shift this motor at 7,500, it should be pretty happy. But that's all stuff we'll have to figure out when we decide what cam we go with, because that'll determine where the power is. So there you guys have it. That's a little F100 update for you guys. I know a lot of you guys were curious about what actually happened to the F100. I don't certainly know. I'm going to pull it apart, obviously, and really dive into it. But I have to finish this car behind me. I'm pretty much giving myself the month of December to put this car together. I don't know how far we'll get. I'm pretty much going to be jamming on this car. You'll see it in the upcoming weeks. It'll pretty much be Galaxy video, Galaxy video, Galaxy video. I have a couple intermediate ones I'll throw in if I need to. But pretty much this is going to be the main focus for December until the end of the year. So all you Galaxy guys are going to get the videos you want, and then assuming early 2022, we'll be fully building and putting the motor together for my F100. So it'll kind of just chill in the back for a little while, take a little bit of a break. I know you guys are curious about the chassis. That'll come after this car. So you never know. I might just say, give my truck a break, and then we'll just do motor, rebuild the trans, you know, a bunch of McLeod stuff inside of it, make that thing super strong, build a super stout forged studded bottom end, super gnarly D-stroke technically engine for it, and then put it all on the chassis. I don't know. We'll see. We'll just have to see where it goes. I still got the Fox body, a bunch of other projects you guys know, but I'm trying to whittle my way down to where I have just a couple cars to focus on instead of like 6. So my mind's all over the place right now. So I got to finish this. But yeah, sorry a little bit of information and talking with this video, but I wanted to make sure for those of you guys who are new to engines, you guys that are like 20 years old and younger that don't know about this stuff, and you're curious, hopefully this video helped you. So leave a like on this video if you did go and enjoy it and you learned something. Let me know what you think down in the comments below. You're curious about setups, or maybe there's something that I missed or I messed up. Feel free to let me know. But with that being said, thank you guys a ton for watching. Go ahead and grab your hats, shirts, stickers at 99speedcompany.com. That stuff will help pay for this expensive engine. That crankshaft alone, those pistons were almost $800. This stuff is not cheap. So you guys supporting me really does help a lot. I'll see you guys in the next video. Bye guys.